Welcome, everybody. We're doing another Feeling of Computing workshop today. We have Dennis Hansen, who's going to be presenting Artifact. I've been talking to Dennis about visual programming and programming on a canvas for a couple of years now. And I've seen a series of different prototypes that he's created. He created Holograph a while ago, which I think, what's the URL? Holograph.so? Is that
That's right.
the URL for that one? Yeah, so you can play with that one already. But today, Dennis has a brand new system that he's been working on called Artifact, and I've seen some early versions of this, and I believe it has evolved a fair bit since the last time I saw it. So I'm excited to see what's new, and for everyone here and anybody watching the video to see this really interesting visual programming project. So without further ado, Dennis, let's see Artifact.
Alrighty. Now, what is going on? Well, in order to understand, we must first take a dip back into time, which, of course, for me started with probably like a lot of you with Legos and Kinects. Actually, after I got both of these images, I realized I must really like things that go on tracks. Starting with the idea of like simple building blocks you can create complex systems with, also the physicality of it. There was no sort of like hidden implementation to your work. That's I think why we loved Legos for many reasons and Connects, of course. Shout out to the Big Ball Factory. Um, and then I sort of got into CAD and machining in high school, and so it kind of let me dive into the digital world, except in still while keeping that physicality. So it just felt like a lot of fun. And then I went to school for industrial and systems engineering. So this is where I got properly graph pilled. Everything's graph. And I learned that very quickly how useful these things are. Also, I got into SolidWorks, which is what this image is here. Constraint-based modeling was very influential for me. It just felt like you're building this like dynamical system and you can connect these things together in this constrained way. So that was also really bit like influential. And then I spent most of my career as a software engineer. So in school, I learned programming, and then I went to start a technology company called Knack, which is a peer-to-peer marketplace for tutoring. We sold to colleges. So I just built like a ton of like software, like front-end software. So I got into engineering, but most of the time I was doing design, product design. So it kind of just gave me this lens of like design systems. Remember when that was a hot word? Um, well, you kind of got some of that Lego-ness, right? With our componentization and like composability. You're still sort of fighting the DOM and React and all these different things, but at least you got some Lego ability there. And then as a part of Knack, I also this was like my first foray into like visual Canvas stuff. We built an online classroom. So this is what kind of started getting me thinking like everything almost seemed easy or to build when you use like design systems, except once you get into like the how do you make a really understandable experience, like that's when the canvas starts coming in and you have all the freedom to make things understandable. And so I started thinking like, wow, this is like the place in this software that actually has like the most potential. We could build anything in here. And so that was sort of in the back of the mind. And as I started to eventually move on from that company, a funny thing happened. This has probably happened to many of you, most of you, maybe if I've learned correctly about the FOC community. But once I experienced like Brett Victor's work, I felt maybe less alone in like my frustrations with building software. And he kind of showed like, yeah, like you can, what if you could see like time, or time was something that you could change and maybe the system wasn't so like hard to understand. And it could be manipulated and all of these different concepts that, you know, will entirely derail or set your career on a new path. So, still trying to figure out which one of those it is for me. But anyway, after this, a few months later, I drew this like first little iteration, which was my thinking was just like ultimately like GUIs will give you like a lot of like manipulability, but eventually you're always going to hit something that looks like code or feels like code that does like low level computation. And so visual programming was like sort of like maybe an answer in my head and maybe something that a lot of us have thought about. And I didn't really know what it was or how it worked, but at least got me thinking about creating these sort of diagrams that were alive. So I did a lot of research at this point, and this is when I started really going to the rabbit hole, found lots of the visual programming environments that we're all familiar with. My first attempt was Flux, um, which is just like a really basic like flow, feed forward. It's like what you'd expect from like a visual programming environment. Things move from left to right. So when I update these numbers, it goes in this multiply and updates this hello world. This is like a little switch. So as I turn these on and off, it goes through the XOR. And there was nestability, right? So you could sort of see the inner workings. So it kind of started playing with some of these concepts. Nodes themselves, I imagined you'd have this, all of your constructions would live in these nodes. And but at some point I was like, okay, time to implement a factorial or a Fibonacci and a loop and a branch. And it just didn't feel like this sort of model would really like lend well towards making like looping and branching and all the kinds of things you need to do computation. So that's when I had a conversation with Ivan actually, and was kind of had a little bit of an existential crisis, but he sort of challenged me in a way where he was like, "What about like what if we didn't like think as much about nodes and wires? Like, what is like the experience that we want to create?" That was sort of the impression I took away, and I started just thinking more about like less about like oh getting like computation right, more about like creating an experience that I was going to enjoy like building and programming. So I had this like interesting idea where I was like, okay, I'm gonna start with like a graphic editor, basically, a like a vector editor. So imagine I would just like draw a line here. My hope was that maybe in doing this, I would figure out like how the computation worked. So this kind of was like an interesting example where it was like, just imagine like I'm drawing a line, I see the dimension. I draw another line that's sort of constrained and connected. You could see that dimension, and then I draw a third line. And then what if I took this third line and I made it somehow the sum of these two prior lines? And then what if I could do like some dynamic repetition of this? And then in doing so, you would get your Fibonacci sequence. So in a way, it was like these patterns of geometry would well from it would fall out computation, and maybe that's how you were going to do computations. It was going to be geometric, and when you zoom into things, there's just shapes and all of these other abstract ideas, which I still think are interesting, but eventually I kind of ran back into this problem of like, how does data move? Like, how does data get from one place to another? What is this something, right? And there are kind of like these unidirectional and there are these bidirectional relationships. And at the end of the day, like computers only understand unidirectional and just like, yeah, just kind of thinking about what, like how data actually moved. I also was really deep in research, and this is sort of at the time I came across propagator networks. And propagator networks just kind of like sprang on me like it was just exactly what I needed at the time. It was a way to represent computation in these like distributed like node graphs, and they could allow you to do loops and branching really easily. And also you could sort of store partial information, whatever that means, but it allowed you to create constraint systems from this. So it felt like this very universal substrate of computation as he sort of describes it. It just felt like a new way to like solve some of the problems I was having. So I said, screw it, I'm just going to try to make um, an implementation of this that I could play with, so I could actually like, see what these things look like. And that's what led me to like building Holograph, which is just a really simple implementation on TL Draw. So this is Holograph. So I can just I have this little uh, propagation mode turned on, but I'll turn it off for a moment. So a lot of you may have seen this already, but I could just update this value. And so actually, if I turn this secret tracking mode on and I change this value, you can actually see, well, as soon as a circle changes a value, then all the squares will react to any changing circle inputs. So it can create these like chains of computation. And most interestingly, you can do them bidirectionally. You can create loops. So, this is like feeding backward and eventually gets to this like stable state. So yeah, I was like, this is great. This is expressive. You can compute anything. But is it ergonomic was kind of the question that I eventually faced. Is like, how helpful is this in actually like building things without like tons of boilerplate? Um, so this was sort of like a funny example that started to bug me is when I was building stuff with these, which to give you a little hint of the kind of stuff you can build, this was a neural network that was built in holograph. So if I click this start training button, it will actually start training this neural network and it will take samples, feed it forward, do back propagation, and actually um, you're able to actually learn things. So it does work, but it's sort of challenged. Oh yeah, I have propagation mode on, so things are moving slowly. There we go. But eventually, in building things like this, it sort of challenged me to it's catching up, so that's why it's going so fast. But it challenged me to like test this system and like see where it went wrong and where it was kind of annoying to make things. So one of the biggest problems was things downstream stuff only sort of changed when um, well, they only like sort of ran when something changed. So if I change a value here, let's turn on propagation mode. If I change a value here, well, you have this funny thing where this downstream cell actually updates twice, right? Once it updates um, based on this arrow, and then because it's reading this changing value, and then this value changes, and then it runs again. So you have like it running with like stale values. So it kind of felt funny. Um, and if you had all these downstream computations and one of the intermediate computations didn't change, then this propagate the subsequent propagator wouldn't run because it didn't see a change. So just like if you were trying to do something like this, like send a daily report, get the weather, get the schedule, and then send a text message, you don't want it to send two texts, right? And sure, you can solve that problem by adding versioning or timestamps, and there's ways to get around it. But ultimately, the problem was like you didn't have synchronicity. Of course, you didn't have synchronicity in a distributed network of nodes that has no synchronicity by default. How do you introduce syncing that allows downstream computations to sort of wait for their inputs? And also, there's a similar problem with looping, which is like, how do you make sure you sort of like, no matter how fast I click, it's always using the latest value. It's sort of running through all these clicks, and it's not just sort of you don't just have to wait. Like in the neural network example, you literally had to wait for the whole network to sort of go through, and then you could give it the next one, or else you're using stale values. So, so yeah, they were just in this async world, in this distributed node world, you didn't have this ability of syncing, and that was kind of what bugged me. I didn't want to have to add all this boilerplate to get that. So I started thinking about what is the experience that I want to create, and one of the exercises I did was um, I started thinking about like how the data moves through this thing. Like if you think of all these things in actually different places, like how does stuff actually go through it, right? You start, let's say, from the cell, and then that updates this propagator, which then kind of pulls this value, brings it back, and then moves forward. There was kind of like this like non-explicit data flow, like or I should say execution flow that goes through this thing. And I was like, what if? Oh, all my words are gone. I had a little machine here. Oh, that's too bad. But I was gonna run these through each of these head statements. But really what I was gonna say is what if all the data that moved through this graph was like explicit, right? And in doing that, you could see this little check mark go from one cell to another. And then it was saying, what if the messages were actually real? And this is what I was going to show Ivan because this was his suggestion that you could take these packets and move them around, and actually the data that moves from one thing from another is like a real thing. Um, and then the last one was going to say, and what if coding was like Factorio? Because this was the time that I actually got super into Factorio, and it just felt like a dream. Like, what if programming could feel like playing Factorio? So anyway, that's what led to the idea of Artifact. So 16 minutes in, now at least when I show you this, I think it will make sense. So the way Artifact works is I'll just do something simple and then you might get an idea intuitively. So things don't actually run until they receive their inputs. That's sort of like the key thing. It works based on an actor model. So every node is kind of like an independent machine that doesn't need to know anything else about the system. But you can use these to compose, you can compose them into synchronous systems that actually do computation that you might want. So let's kind of just like explore how it works. So the sort of basis is like these two shapes. You have a cell which can store value, and you have operations which have operations and just really process values. And uh, and you can draw, of course, arrows between them. And they actually have these like default inputs and outputs that could be overridden and changed. And then I have this, I'm in select mode, but I can go into this interaction mode and I can send a packet through. So actually, these cells by default, when you click on them, they just send their value, which is kind of like a utility. So let's send another value, right? And then let's try to get this thing adding. So if I press play, nothing will happen. I can actually reset this and then send this value. And again, this will not run until it has its input value. So now there's some other cool stuff that can be done. Cells, well, actually, they receive a value, but they also emit a value. So by default, values just keep moving forward. It's not just reacting on change. So I can create like a thing like this where as soon as I send this 5, it just creates a loop. And now it's waiting for the next one. Great. Um, maybe I want, every time it loops, I want to send this 34. So there's another interesting thing you can do, which is cells don't actually have to send their value. You could just send an execution signal or a pulse that just says, hey, don't send a value to override this value. Just tell this cell to send itself. So now if I do this, that pulse. So now I'm actually going to pause time and I can go backwards. Of course, we get time travel for free since everything is sort of tracked in the same system. And I'll press tab, which is just a way to run anything that can run, which helps me to debug. So we can see that as soon as I press tab, it goes through this execution arrow and sends just a little pulse, and then that sends 34. So that gives us ways to sort of create these execution dependencies and get values to send themselves. And what's happening under the hood here is this is really just setting some defaults. What I just called the port go, which is what sends and receives these signals to do this execution. Um, so cool, we made a little looping machine. Well, let's turn this into something, I don't know, halfway useful. Let's say we wanted to do like make a counter, which is sort of a classic starting example. So instead of having two inputs, we could actually just we could switch this to +1, so you could actually put like a sort of carry value in there. And now we have this little machine that will just keep adding 1. And then let's add a button. And then the button can go into we could just have an execution arrow that then goes into the +1. So now it actually won't run until, I'm going to move this so we don't have all this other distracting stuff around here. So now when I press play, every time I hit the button, it will, oh, I'm in fast mode. I didn't tell you, but we've been in a secret slow mode, which allows things to move slowly. But now every time I click the button, the dependencies of this op are met and you can increment up. So, um, so there you go. So now if I reset the system, all right, and I press the button, well, nothing happens. So that's what's kind of funny about the system is like you kind of need to kickstart this by sending its initial state so that subsequent button presses will actually increment. So that is why we have the start operator. So the start operator will just send an initial value whenever the system is started or reset. So now when I reset, it sends the initial value, and great, now we have our counter. So a funny attribute of this is it also opens up, or from this sort of falls out the ability to do like defaults. So if we want a default start at 1 or 0 rather than the initial value or the previous value, then now when I restart the system, great, it starts at 0. And now we can keep sort of counting. So one of the sort of big parts of holograph that I loved and obviously I want to continue with is like the fact that you could like edit these shapes and that the shapes sort of live in the same world as the code. So let's do a little example like that. What if every time it was even or odd, like the button just said even or odd? Well, let's implement that. So, and in doing so, maybe we'll learn something new. So, so let's say modulus 2, and that will just go into a cell. We'll see what that comes out. So I'll just delete this and then just create an arrow. So let's restart. Great. So it sends out initial 0 value. Okay, so let's just detect if it's 0. And um, and if it's 0, then, well, what are we going to do? Well, I guess what I'd like to send the new text to this button. So let's say it's even, and we want to send that text to the button. So we're actually going to change this port to say text. And then, okay, so we want to trigger this even to send to that button. So we're going to use an execution signal so it doesn't override that value. And so by default, these operations will send like a true or false value. So like if I went forward, this would say true. But there's actually these special ports that these operators have in this conditional form where you just say yes. Now it turns green. And now if it's true, it sends. If it's not true, it won't send. So if I make another one of these and I call it no, now it won't send on the no branch. So that's how you get branching. Um, so, well, let's actually use that no branch. We'll make it an execution arrow, and we will, let's see. I'm using lots of hotkeys here under the hood, if you didn't notice, but let's do odd, and then we'll send that as the text. Um, and we'll see if this thing works. And then I'll set this as no. All right. Well, we already had that signal going into the even. Great. It sent that. Let's click it again and toggle and see what happens. 1, it checks it. Is it equal? No. That means it's odd. All right, it sends odd. So let's just press play and see our little machine at work. All right, so it seems to be working. We can then move it to fast mode. And now it's just your app that's actually running fast. And it just kind of shows the last packet that's changed animate in. But yeah, that's kind of how you make little machines. So that is, yeah, that's conditionals, that's the operations. From that, you get some other cool stuff that I'll show. And then yeah, let's poke around. So this, like, what the heck is this thing? This is a factorial. So now that you have some understanding of how this stuff works, I'm just gonna do stuff, and you're gonna be able to just kind of see it float around and compute. So what's actually happening here? So we can kind of run this in slow motion, and it'll introduce a couple new concepts. So this fanning thing at the top is just a way for me to send values in and kind of test this network. So let's pause time and just send in like a 0. Well, as soon as it gets here, you could see that every time the network loops, it actually it restarts this start, which sends an initial value. And every time you reset, it sends an initial value. So this op doesn't actually have an operation. It's purely being used as sync. So it's actually just blocking off this network while it waits for the next value to go in. So one thing, I don't know if you noticed, but these values can actually queue. So you can put, so all of these arrows aren't just storing one potential single value. They're storing as many values as you want. So what this sort of circular operation here is doing in this blocker is it's just making sure the network again is not occupied, and once it's opened up, then the next value can come in. And yeah, so you end up using this a lot of times when you want to operate on the output of previous computations. So so let's look what's happening here. So let's start with 0. It gets unblocked. So there's a few special cases for factorial. If the answer is 0, well, or if the x value is 0, then 1 is the answer. If it's 1 or 2, in both of those cases, that input is the answer. But it's only when you get above that that you want to start doing computation, right? So you take that value and you set on the left, you set an accumulator value, and then on the right, just a value that is counting down. So 4 times 3 is 12. You check if that countdown has got to 2 yet. Nope, it hasn't. So this is like showing a new concept here, which is you've got these different inputs, right? A, which is the first value in the A is technically being shown here. Some of these things I would like to be a little more explicit without having to dig in, but um, so you're checking if A is equal to 2, and then B is going in here, and it's just waiting. It's just waiting to see if A is 2 or not. And then these outputs actually have a specific value. So what's cool about all of these operations is they're also doing routing. So, so by default, the A value is going to be sent out through any sort of yes or no output. But you could do something like this. So if I click on this, this is actually no B, which means that when no is when it's when it's false, then it will send out the no branch, but it's actually sending the B value out the no branch. So you could basically route any of the inputs to any of the outputs um, when the condition evaluates. So that lets you do things like this, which is, you do your computation, you're checking if 2 is true, and then if it's not true, in this case it is. So let's go back to when it wasn't true. Let's do another round. In this case, 5 is equal to 2. Nope. So then you're routing back the accumulator and you're routing back the countdown. And then eventually it's true. And that brings you to your answer. So that's routing. That's probably the last key concept. There's some other cool stuff that I can show. This is a little slideshow. So you can imagine, I've shown you switches, or I've shown you operations, cells, buttons. You can imagine there's, primitive elements that from which you can compose all these complex elements. But I have sort of a smattering of components here that at least illustrate some of the potential. So one of them is this image component. So what is this thing? Well, it's just a slideshow, right? So if uh-oh, my, I guess my development server wasn't running. Let me actually just get that going real quick. This is, it's deployed, and actually I would like to get some of you guys on it, um, but we're playing in dev mode right now. So let me just npm run dev. I am using, Vite. So, um, so let's so let me reset this, and then I'm in fast mode, and I'm gonna press play, and great. It's a slideshow. It works like how you think it would, right? Forward, backward, selections of images from my youth. Um, and but how does it actually work? Well, you can guess, right? We're inputting either a 1 or a -1. We're then adding it to the previous value. And then we're smashing it between 0 and 4. And then we're taking that value and it's going into this switch. So you can see the switch actually, the input is case, and then the output is all the different cases. So in this case, it's going to come out the 3, which is an execution error. So it's going to send the image, and then great, it just sends that image. So this is a little sort of doodad, little widget. Everything's kind of a widget in artifact world. But um, but yeah, you can kind of see how it works. That state is just being tracked there. And again, every time I reset the system, it's just sending that initial value. So that's the switch. Um, so it shows some other interesting stuff. What is plugging away over here? So we have this basic, um, it's like a timer component. Yeah, it's like an interval. So yeah, it just sends like a new pulse every second, and then you can see it sends hello world. It can evaluate JavaScript, kind of like holograph, and just grabs like the last 2 digits of the timestamp. And yeah, so you have this little machine, you can kind of point this thing like wherever you want. It's just going to accumulate. Um, maybe you want to, I don't know, send a bunch of pluses over here. I mean, the system is kind of like it lends itself to being messed with while it's running and kind of just like playing around. But yeah, we'll keep that running. This is a simple incrementer. So there's just like a text input, and then you can just add one, -1, reset. Um, then we've got this is kind of a funny thing. Text inputs are surprisingly challenging. Just as a general, just the way they work, the DOM handles a lot for you, but in this world, like we're figuring everything out from scratch, I guess. So this introduces another concept, but the way I've sort of modeled this is like it's not um, default. It's not sending new values every time you change. That all of the changes are actually coming out of this, like any I make to the put are coming out of this little change arrow. So that lets me intercept the change before the value is propagated out. So I could choose to reject it. I could do input masking. I could do anything like that. In this case, I'm actually just routing it right back into value, which then sets the value so you can see it and then propagates it along. So in this case, you could see as soon as I type the value, so if I type another 0, you don't see the 0 immediately, but because it is intercepted, but then it comes back, it says, yes, this one is fine, and then it goes through. And then it does a funny thing here. So this is kind of like, I'm trying to figure out if this specific keyword is like a foot gun. It probably is, because it might introduce sync issues, but you can set things without continuing to propagate the value along. So this is for like this in a way it kind of opens up race conditions, but sometimes you need these things like if you have a value that is continuously updating and then you want to just sort of grab that value at any given time to do some computation. That's sort of what set is for. So in effect what this little machine allows you to do as well as you'd expect, you can you can translate from Fahrenheit to Celsius and you can go back and forth and it just kind of propagates one way. Um, so that's that little machine. This is a cool one. I just call it a swap, but all it does is every time you click the button, it sends in a different direction. So it's kind of like a little, railroad switcher, but could be useful for a lot of purposes. Um, this is a different toggle, but it's just showing toggling the color. So it's actually just negating this value and then sending through true or false similarly. Um, this is kind of a fun one. It's like I'm not sure what it is, but whenever I click the start button, it will start sending pulses. And well, I have hi-hats, I have kick drum, I have snare. And while I can't make a full song with it quite yet, I can do like I can do a little build up. So if I put this in fast mode, I could just half the delay and then starts going faster and then it goes into our build up and the drop, I guess. but at least this gives you like a sense that you can have different kinds of like interacting elements. Sound, of course, is a fun one. And you can see the scheduler isn't quite perfect yet in terms of its timing. But getting things to run smoothly and performance-wise is, never-ending challenge. And yeah, let's see. I mean, that's pretty much it. This is maybe the last one, which is this is kind of I'm still not sure what to make of text inputs. There's a variety of ways to potentially implement them, but this is an incrementer that lets you actually validate the input. So um, so if I press play, let me turn off my crazy sounds. I'll turn off this other one too. But but this is kind of an interesting one. So this allows me to change the input. When I change it, um, what it's really doing is it's just it take like the state of this input is sort of in a way like living in front of this switch, and then we either take the change and commit it, or if someone presses a button, we increment it plus or minus. So and this allows us to have an operational input that you can change, right? So as I make these changes in the input, they will propagate down. And then you can do plus and minus. So I'll just show this sort of working. But if I uh, do a value, or I'll do this in slow motion. But if I do a value, you'll see the change. It then saves that change, and I can intercept that change right here if I want, or I can do minus. I could do plus. So this introduces this like interesting property of these like systems, which is um, you don't you don't want to have like you don't want to process stale values. So even like if you have changes that are interceptable, like these where they actually leave the system and then you can process them before they get back, well, then you have to wait for that to happen before you can do, for example, a plus one. So if I add a number in a, let's do this in slow motion. If I add a number, let's do this one more time. Let's do 5. Let's do it one more time. All right, so now you can see like 5 is the next value because I just overrode all of that. And then I do plus 1. Now, first it needs to process that change, which it will do, and then it does the plus 1. So that's kind of like one of the interesting points of like I would say that the criticism of this system, or at least the interestingness that I'm trying to navigate, is like is when you have like a state variable and you want to do some processing on it. Um, you kind of you only really want to do one kind of processing at a time and then wait for it to come back before you process it again. So in a way, you end up using these switches a lot, where you're like, I have this value, and then I want to add it, I want to update it, I want to multiply it. You kind of can go out in any number of these directions first before it comes back in, and then you do the subsequent computation. So it's kind of just like an interesting way that some of these systems work. So anyway, I don't think Artifact is necessarily the end all be all of visual programming, but I think there is a powerful thing we can do when we just take the actor model and we use it to like program different primitives and then see how we can make these computational systems. So I'm constantly trying to like reevaluate and make ways of programming that are better and more fun, because I think when you solve fun, you kind of are forced to solve everything else along the way. So anyway, that's Artifact. That's my project, and I'm definitely curious to answer any questions or dig into any quirks or clarify anything. I know this one is probably the most complex and funny and quirky, but you can see how the goal is to make some of these systems elegant. And yeah, so I'll stop there and open it up to questions and comments and all that good stuff.
That was awesome, Dennis. Very cool. Yeah. I have a handful of questions, but I want to let folks in the other attendees kind of have a crack at going first and see what comes out of that. So if anybody has a question, oh yeah, okay, Juk, go ahead.
Uh, so very cool. So is it also based on TL Draw?
It's actually all just SVG and React and absolute positioning.
Cool.
I tried using like WebGL and all these different like Canvas tools and uh and and honestly the reason I picked SVG in the beginning was because AI could generate it really fast and I wanted to just iterate quickly. But then yeah, it just ended up being easy to use.
Okay, cool. And do you think it's going into production? Like would you use this to create like production level code, or is it most for teaching, or what's the usefulness that you see in the future?
Yeah, it's funny. I just watched this interview with like Ilya Sutskever and someone asked him like how are you guys gonna make money? And he's like, I think it will reveal itself. And everyone's like laughing because they're like such a dumb answer, but that's kind of my answer. It's like I
Okay.
think the answer of like what to do with this thing will reveal itself. I'm not really sure. I definitely want it to be used. So I do want to create a thing that people can use. That is my goal. But I know a big part of that path is like making something that I really enjoy using. And I think if I can get myself in that loop of like making it better and better and start using it for stuff, then I'm hoping I can open that up and see how other people use it and start to align those things.
Also, and what you said, like if it's playful, I'm not sure what you said exactly, but if it's playful, it's a good test to see if it's actually good to use. That's very
Yeah,
true. Awesome.
exactly. Which I'll add a comment of like, if we're entering the age where like uh everything is automated that we don't want to do, well then what's left? Well, the things that we do want to do. So, I don't know how much are people going to program unless they love it, right? How much are people going to make stuff unless they enjoy it? Well, like let's try to make like ways of creating that are fun.
I love it. I love the smooth animations when the events arrive at the next node. It's really making it more kind of visual. And there is one capability of programming systems that programmers take for granted. And I see that's missing in many visual languages. And it's the ability to represent records, like
Hmm.
collections of complex data, like first name, last name, email, databases, this kind of stuff. Or maybe even a step further, like data structures, like linked lists or stuff like that. I know they are not here, but do you think it's possible to make them compatible with this sort of network?
Yeah, that's a great question. There's definitely some like big challenges I think visual programs are going to face when it comes to like representing more complex things. And some of it might stretch. Well, I think if you try to like force everything into a node wire world, like a lot of those things might not be as obvious, but I mean the goal is to make something that is useful and fun to use. Um so it doesn't have to be node wire. Um, so yeah, to answer your question, yes, I do think collections can exist, and I've thought a lot about how to implement collections and data structures. And I think my best idea of it is that in some way it sort of synchronizes with getting UI to be built in sort of a composable way. So I kind of have this imagining of like you have cells as like this like atom of data, but having the ability to sort of drag and drop and compose these into like lists, having some kind of like list UI primitive that you could then create these like lists where then you can like send data directly into specific values and out of the sort of greater
Mm.
uh, structure can come your lists. So that's how you can go in and out. And then once you have this sort of set or list component, you can nest those and you could have a similar component that's like a key value and just kind of nest them in whatever way you want like graphically, but also you can extract the data and do like um, data manipulation on that stuff. So I think
Those
it's,
input ports are kind of nice because they kind of give you something like methods, like you can invoke many different input
yeah,
operations on the same object. Yeah. So
exactly. Yeah. And I think that'll give a lot of the sort of usability for like the everyday purposes. And I think once you add like metaprogramming, then you could do then it's like, okay, I want to like dynamically create these structures that are connected in this more interesting way, you know. Like trying to create a neural network, for example, is like trying to do that manually. It was like copy, paste, map all these different things. But the reality is a lot of these like structures, well, I almost would say definitionally, the structure mean there is a pattern of connections. And if you can represent that pattern in some way, then you should be able to dynamically repeat it. So I think you can get a lot of the like between like the data structures and dynamic repetition in metaprogramming. I think you can get a lot of like the algorithms and sort of weird computational graphs that you might need.
Blixt asked in the chat, very smart system. Two things that come to mind. Encapsulation, like the timer
Mm,
could be made from primitives inside and just push into a special how I show one layer up box for rendering. And what
hmm
about concepts of life, like self-replicating and destroying instances of an encapsulated agent? I guess this naturally
Yes.
leads into a third question. Would you consider rendering in a way where things can move around? And they say, if you
Mm,
remember my game I made in Holograph. Huh. So
yes.
yeah, questions about encapsulation, about nesting things inside other things, rendering inside and outside.
Yes.
These are great questions.
Blix was like the first person that like made a complex game with holograph. So it was like a cat and mouse game, and it was, as you move your item around, like it would sort of lerp this like cat and follow your cursor, which is holding the mouse. It was really cool, and kind of shocked me in the capability of the system, but it did require like this sort of XY movement. You could adjust like the location of these things. So on that, like, yes, like I want to add all of anything that is being rendered can be modified, right? Including position, and things can modify their own position, that things can move around. So I want to just increase the amount of flexibility to the point where like eventually, like, you can create and modify points and lines and planes and shapes and just grow the flexibility of the system and how much the code can adjust what's rendering. Yeah, around encapsulation, I think as a part of that, like yes, like encapsulation is absolutely necessary. The interval component should be made of like a delay or something simple, like a simpler primitive, like a delay that maybe like a system clock reader. But I think the tricky thing about encapsulation is like in my previous life, or I guess in my previous like projects, like encapsulation was just a simple thing of like you take your node and you take your group of nodes and you just map all the inputs and outputs to this new node, and then great, it just does some internal computation. But now there's like this how does the UI or like how do you actually construct UI from like what's from this collection of nodes? So I think Unit actually does a good job of this. They kind of have like a separate like view the components versus view the code. And only some of the components are like viewable. I'm still not exactly sure how to solve this problem, but I think the experience I'm trying to or the unifying vision I have is that you have some set of items, you can sort of click them and group them, and then rearrange them, conditionally display some of them. And there might be this like UI editing system that like potentially WYSIWYG, but I really, as much as I can imagine, is like you can modify the constraints between these things. This thing is inside of this thing. This thing is like can't is like this distance away from this thing. As much as I can use like a constraint-based editor, I will try to. But yeah, those are just some ideas as far as encapsulation goes. And oh, and another thing he said, which also is a really good question, is around creation and destruction, which is like yeah, that's absolutely needed for like metaprogramming or just like, you know, particles or emitters or really any kind of like more dynamic creation or destruction of objects. Like I would like each sort of, I mean, the actor model actually kind of hint like already thinking about this, but any object I think should be able to like create other objects. right? And you should be able to like read the data of an object or emit your own data, and then that data can be modified. And then, yeah, I would like to see like objects having like birth and death capabilities, basically. Like you can die, you can replicate, you can send your sort of DNA around.
I know some concepts in programming, but I'm far from a routine programmer. But over the last more than 2 decades, I am thinking about things like these, and I'll just throw in a few ideas, and you can make sense of them maybe. One is that I think it was 23 years ago that I had at university a thing on real-time programming, and we did Occam. And beside the code, where you could easily make a typo and it wouldn't work, we had the for illustration. There was a drawing which was very much like a chips connected, like in the VHDL. And then I thought, oh, but I want to have the illustration change if the code change, and vice versa. That turned into me organizing conferences about SVG because I needed that to put it on the web. Another thing is when I see people on a whiteboard drawing nodes and edges, they're mostly drawing something, and while they do it, they speak, and then later they write it down. Nowadays, with speech recognition and powerful machines, can we maybe actually do that? So I just put my finger on the touch screen like this. While I do that, I speak, and there's the arrow, whatever I mention. Those are two. And you were talking about composability. Would HTML components be a thing? And the last remark is during this university course, in the book it said, the world is parallel. Why not model it like that? And then I was like, yeah, all the multi-threading I read about, I cannot process because you start to do it linear and then a few linears and try to combine them, and that's difficult. But when you start out with the parallel model, often it's easier to comprehend. For example, I had a board game 5 against 1 on a checkers board, or every square on the board was a process. And to stop it from going off the board, I just surrounded it with some stopper processes. So that was, yeah, starting out parallel. This is just the few things that come up.
The world is parallel. I think that's actually a good like yeah, the way you're talking about parallelization also, I will say, I think makes sense. A lot of when in the graph world, like graphs have like this inherently parallel nature. This is like an inherently distributed computational world, so it kind of begs a distributed or parallel way of thinking. So yeah, I think approaching problems, writing algorithms, it's like we're typically coming from like linear world. I think it does beg like a slightly different way of approaching problem solving. And as I've programmed in this and learned it, I've like had to sort of readjust like how I think about programming. It's been fun. It's like a kind of like a puzzle to figure out what the right or like what the best practices are for making stuff in this new way.
My question was, it's one of those sort of forward-looking, like, hey, what do you want to do with the
Hmm.
system kind of questions, but I want to scope it to like, what are you going to do right away? And I'm curious to hear you talk a bit about when it comes to the sort of visual communication of the design of this
Hmm.
system. So the way the nodes look, the way the edges between nodes look. I know from our past conversations that you are a very talented graphic designer. You've done a lot of really cool graphic design work, and I would say that what's here in Artifact is really restrained. Like you are using very simple visual language, and so I'm curious to hear if that choice to keep things visually very sparse and simple is an intentional choice, or if it's something where you want to get a little bit more elaborate. And if so, like what are you planning to do next in terms of advancing the visual design of Artifact?
I would love, okay, so that's a good question. So first, I'll just say I would love if Artifact was like minimal when you first picked it up so that you can easily absorb it, but then you can go into like high energy mode or like calm mode or whatever, and like it would become themable so that you can things can appear in ways that is helpful not just to like once you know how the thing works, then you could the additional design sort of like your additional attention could go towards like driving a specific feeling. So there's a designer that I worked with that is very much he's like one of the most incredible designers I've ever met. He has like intense form of synesthesia, but he's good at like encoding like different feelings in how things look. So I just threw him Artifact and I said, what would happen if like Artifact was like in this crazy like design style? And this is what he came up with. So I think it just paints the picture of like this could look insanely cool and crazy and awesome, you know? And it's like all of these different things, like every single node, every single like element on the screen could go towards like very intensely driving its purpose and driving a specific feeling. So this is like, you know, high energy mode in his design style, which he calls Hex Dragon. But I think it was a really fun experimentation because it's like, what would it feel like to use something that you're just like, hell yeah, this feels so awesome to use. So that was sort of one thread. Um, but yeah, also using motion, using like organic shaders. Like I want like data that's moving through the graph to feel like it's like pulsing through and like the animations like happen snappy. Um, but yeah, that's just as far as the graph itself. I do believe that as visual systems evolve in general, that the way each node looks should become much more um, useful for what its specific purpose is. So like a timer node, for example, like might show you a lot more information or graphs about like like things that happen over time, or like addition nodes might show you some like visual of like the proportion of its inputs or whatever these different things are. I just think it's almost like you go deeper and deeper into like every single element on the screen, better communicating its purpose in its context. Like that's kind of the vision.
Yeah. So I'm going to take moderator's privilege and ask the question again, slightly more focused. I know that there's a huge possibility space for things that could be done, but I'd love to hear
Mm,
what what's most itchy to you. Like, what are you
okay.
personally
Yeah.
going to do
Yeah.
next? Like, what's the
Yeah.
top of your list for things to do?
Yeah. Well, there's one really itchy problem for me, and it's marrying flow, this like I don't want to call it flow-based programming because it's a little different, but basically data moving around in these like unidirectional flows versus like constraint-based systems where you have like bidirectional equalities and a lot of what Crosscut was doing, right? Where you have like you're almost like you have constraint systems, you have solvers, you have layout systems. A lot of these things work by you either have these sort of distributed like propagator networks that like do constraints, or you have like these central solvers like but ultimately there is this world of like how layout is calculated, and then you have this kind of like data flow, execution flow world, and I want these to all live in the same world. And I'm still not sure exactly how that works, but I know that it's possible, and I believe propagator networks hold the key to that, of like finding how to how to move data around, potentially partial data around intervals and sort of like converge on intervals. So I kind of want to go back into like experimentation mode a little bit and see if I can feel out how I can basically ultimately give myself the ability to construct like layouts in this system in a way that feels good, and also a way that where it sort of works by the same principles of the flow-based programming system, that the constraint system of the layout system and the how data moves in general is sort of all shared in the same system.
The like infrastructural level changes to how rendering is happening and how stuff on the canvas is represented.
Yeah, something exactly. And like it's something as simple as like if I just want to say like all these things are like like vertically aligned, like how does
Yeah.
that appear? How does that actually computed? How can that be overridden? How can I create constraints where like this is X distance from that? This is inside of that. This sort of constraint system like feels like almost like a whole other computational layer, but I would love to find a way that it shares the same layer and that it's inspectable and modifiable and they share the same primitives. So to the degree to which it is possible, I do not know, but I'm sure it's possible, I suppose. But I just haven't figured it out yet.
So during the presentation, you mentioned a couple of times React. I guess it's implemented in React. When I hear React, in my mind, React doesn't dovetail well with multi-threading and parallel computation. Do you think it's helping you or maybe causing more difficulties?
Yeah, it helped me in the beginning. For a lot of this was like, well, I don't like, I think there's like a way to use to represent packets and do syncing, and maybe that will let me program things that are useful and like in like an expressive general purpose way. So it was all about just like speed of iteration, but it is becoming increasingly cumbersome. And I mean, my goal really is that like I can program artifact and artifact, right? Who building a software design tool doesn't want to build it in itself. Because then you get into the hyper feedback dogfooding cycle of building artifact is actually getting feedback on artifact, is actually improving artifact. It's just like the ideal. So I've kind of, that's like another big itch that I'm always thinking about is like, how do I start to like replace the internals or take more of artifact and like build it inside of artifact? Because then I can and part of that I think is it might just like I might not be able to do that immediately. I do think there is potentially the necessity of like building a graph execution kernel that runs in C or something something that can compile the WASM and just makes better use of resources. And at
Hmm.
least then I have a fast graph. And but even then, I'd love to eventually have that kernel like written in Artifact itself. I think I can just like as needed try to explore like building more things in Artifact or speeding things up through WASM.
Like I play with these sort of data flow graphs a lot, but in a different environment. And I've also hit this problem of you have to sort of sequence things and have these synchronization blocks and stuff. And I feel like it's because we have this static data flow graph and you want to layer on recursion or reuse and it's difficult. It fights you a little bit. And that's what the synchronization blocks. But then I think like maybe these just aren't good computations to run on this fabric. And then the kind of things that are good, they do have a static data graph, like represents the algorithm quite well. And I'm thinking like state machines and things like that suit this a lot more. So I was wondering if like an IP datagram decoder or something where it's just like bits coming in a wire and you figure out what state you're in.
Mhm.
That's sort of my suggestion is like those kinds of algorithms might come out better or cleaner.
Yeah, no, I agree. I definitely think like there are, I would say, yeah, like a state machine or just like, yeah, complex like state representations and moving between states, like visual world is like you get a lot of benefit from like moving in the visual world. Some things less so. But I think part of what I'm trying to do are there visual representations that are just kind of like that get better across the board that allow you to do and that can be used for like the full variety of computation. I guess the universality of it, the general purposeness is sort of what I've been seeking. So a lot of like the idea of doing like recursive computations is it's kind of just like a test. It's like, okay, I have this like programming system. What is it the worst at? What can I sort of like throw at it to challenge its expressiveness, its universality? So that's what's kind of led me to doing some of these like more challenging, like looping and branching things. But yeah, I definitely don't want to like leave the obvious like state machine kind of things on the table. So I imagine in the future, like it's not just going to be like, what is the visual programming language that we use for everything? It'll be like lots of different representations that we use for different purposes. And I think what I'm trying to find is like a way to sort of orchestrate and unify, at least allow them all to speak some kind of language where they could interop. So yeah, I could imagine like maybe there's like a node that's like a state, and then you have the state machines like arrows that sort of like, but under the hood they're actually sending data to each other. They still are these like independent things that are working together to make this like state machine happen. Part of the philosophy of like having things live in the same world but be represented in different ways that are useful for different purposes, and those sort of appear as like different programming experiences. That's kind of my view on it.
Awesome. So just to conclude, there's kind of two contextual questions that are still left waiting to be answered, which is this something that we can play with? If so, where and how? And then also, is this something that you're working on entirely by yourself, or do you want people to get involved? And if so, how?
Yeah, great questions. I do have this deployed, and I would love for you guys to try it. And yeah, honestly, the hardest problem I think I am and will face with this is like, how do I go from this not just being me to like this being me and someone else? So I like that is really what I would love is like for people to like try it, like have ideas, get excited about it, and eventually, yeah, like help me with it in some way. I don't exactly know the form. It's not open source. It may be. I'm still not sure. But I do want people to help me and contribute. So if you're interested in it, yeah, just give me some feedback. Let me know. We'll jump on a call. Like, just get in contact with me. But I definitely want help. I think this is like also there's like another way to help, which is like, yes, help me make Artifact, but also like the actor model. Like this is really just like basic actor model. You have these things that just communicate through these like message queues. There's lots of ways to like build primitives, right? I have like this cell and this op primitive. There's lots of ways to like uh, use these, or there's a lot of ways to use the actor model to create primitives that interact in some way. And I'm sure we can create all different kinds of ways of data flowing through these graphs to do things better. And maybe I'm way off the mark. Maybe we'll find something much better. So yeah, experiment yourself too independently. Like you don't need me. I'd be happy to help and support any projects that are exploring different directions. I definitely think like if we want visual programming to be awesome, it's just going to take like a lot of experimentation and effort and trying things. And I encourage all of that.
That's awesome, Dennis. Thank you so much for sharing Artifact with us. It's very exciting for me to see how it has evolved since the last time you showed it off, and I can't wait to see where this goes next because you're at a really promising stage in the development of this system, and there's so much potential for what could happen. And so, thank you very much for showing it.
Yes, awesome. Yeah, I'd love to keep all of you involved and appreciate, the interest and support as always, Ivan. And I'm excited to show you guys what comes next.